have labs tonight and tomorrow. You can be learning about this on one lab on Friday, all right? Then you see these acid-fast organisms. So this is on a stain. It's called an acid-fast stain. And then you can grow the organism. The organism grows very slowly. It takes weeks for it to grow to this level, all right? You can culture the organism from blood, or you can even do a skin test, right? A skin test doesn't tell you a person has TB, and that's important. A skin test tells you if a person has been only exposed to TB. The person could have TB, by the way. Let me just say this. A positive skin test means the person has been exposed to TB. All right? There's another test that's called quantiferon gold. It's like one of the standard tests that's done all the time. And all I want you to know about this, people who are exposed to TB, their white blood cells produce interferon gamma. INF stands for interferon. So what you're detecting is interferon produced by these white. All right? How do we treat TB? We can use antibiotics, of course. Very few antibiotics compared to other bacteria. Isoniazid, rifampin, pyrazinamide, ethambutol, and then streptomycin. These are all typical drugs that we use for TB. Now, I want to mention this term and remember it. You're going to see it in your practice a whole lot when you guys are nurses. You're going to see this term. Nurses, you're going to see this term. MDR-TB. That stands for multi-drug resistant tuberculosis. So again, there's some strains that are resistant to many drugs that you see here. Very difficult to treat, especially in AIDS patients, all right? So MDR-TB stands for multi-drug resistant tuberculosis. Now, is there a vaccine for this? Yes, there is. It's not a very effective vaccine, but it's not used in this country, all right? This vaccine is called BCG. It stands for Bacillus of Calmette and Guerin. That's what that stands for. So here's how this is done. To make this vaccine, you take a live organism, Mycobacterium bovis, except it's not a virulent strain. It doesn't cause disease. You break that strain up, you collect the proteins. It's actually, it's a live organism. It's an attenuated. So attenuated means it's not very active, all right? But it's live. It's air virulent, and you inject that into the skin. If you're from Europe, you probably had a vaccine, all right? And you can tell because it leaves a mark on you. If you look at my arm back here, my shoulder area, you're going to see this mark. So that tells the signs that you've had this vaccine. That's the BCG vaccine. We don't use this in this country for several reasons. If you have the vaccine, your skin test will be positive. Or there's a great likelihood that the skin test will be positive, even when you don't have TB. So that's a complication. Imagine all you guys at some point would have to do a TB test when you get into the nursing program to go into the hospital. Well, if you had a vaccine, you might have a positive skin test. And they say, well, do you have TB or not? That can create a problem for you, right? So this is one problem that we have. The vaccine is not very effective against kids, all right, in kids. So it's about 60 to 80%. That's not a very active or very versatile vaccine, all right? But there's some other mycobacterium species, don't worry about them. They don't cause respiratory problems. This one does, it's called avial, but again, this is a very rare one, causes misery in AIDS patients. But again, this is not significant here, right? Okay, so we talked about TB. You guys realize that most of the world's population, at least 25% of the world's population, they're infected with this organism. I probably have it, you probably have it. We live in a dense populated area, right? But you probably wouldn't have TB because those macrophages pick up the bacteria and they form this granuloma that's walled off in the lung. Of course, this can break apart over time and then TB can, but that's very rare. It's less than 5% of the cases, all right? Okay, I want to talk about some other organisms that cause lung infections. Again, we're going to see them as we go on with this slide, all right? Okay, so... Yeah, go for it.
Oh, sorry. Okay, so you know how you said that the bacteria is getting walled off?
Yeah.
So what happens to that over time? Like, does it just degrade, or does it have to stay in your lung?
That's a very good question. It stays in your lung, but because it's walled off, right? You can find the bacteria to that focus. In other words, it's not going to spread unless the bacteria reactivates. So here's what happens when the bacteria, people get older. So TB, when you think about people who get TB, right, they tend to be older. They tend to be immunocompromised, and they have some other underlying condition. So in this case, the bacteria reactivates, it starts growing again, and it's going to change this granuloma, that structure that granuloma into something that's softer, and this can now break apart, all right? And then the organism can spread. But you're right, this granuloma is walled off. Generally speaking, over 90% of the cases, it's going to remain like that for the rest of the person's life. So they're not going to get the disease. Does that make sense?
Yes, thank you.
All right, cool. Other questions? All right, so I'm going to move on with some other diseases back here. All right. And I'm just going to mention a few of them. These ones, Staphylococcus aureus, Klebsiella, Pseudomonas, Serratia. All I want to say about this, these commonly cause disease in the hospital. So if you remember, those types of diseases are called nosocomial, N-O-S-O-C-O-M-I-A-L, nosocomial diseases. These are acquired in a healthcare setting. So again, they can cause, they're opportunistic pathogens given the right time, the right type of patient. Patients in the hospital is already immunocompromised, right, or compromised in some form. These diseases, these bacteria can be transmitted to them, and then disease can be resolved. But generally, they don't cause problems in the community. All right? Okay, but all of these, I just want to talk about one of them. It's Staphylococcus aureus. I just want to say a few things about this organism as it relates to the disease it causes in the lung. You guys probably heard about MRSA. That probably rings a bell to you. That means something. It's methicillin-resistant Staph aureus. But what I want to say about Staph aureus and lung disease, again, this is a nosocomial disease. You just happen to be in the hospital, and a nurse or a doctor or maybe your roommate and the other patient transmitted this to you. Now this bacteria gets into the lung. It causes a very nasty pneumonia, very deadly actually. That's called necrotizing pneumonia. So I want you to make that link, all right? So this does not occur in a typical community. But when you're in the hospital, there's a potential for this bacteria to cause disease. And these other ones too, Klebsiella, Serratia, other organisms, Pseudomonas, can cause disease. They are opportunistic pathogens that you pick up in. All right? Let me move on to a few others. This other one here, this is community acquired now. So you acquire this in the community. First on the list is this organism here, Streptococcus pneumoniae. Just a little note for you. It's the #1 cause of disease of pneumonia, bacterial pneumonia in elderly people. So when you hear about older people, grandma dying of pneumonia, bacterial pneumonia, this is the primary organism. It's called Streptococcus pneumoniae. All right? Every year in this country, we have over 500,000 people who get this disease. And 40,000, this is just almost 10% of them die. So this is a really nasty one. So imagine an older people who are very young or an immunocompromised person has this in the lung, that person that would cough up sputum that has this texture to it. This is called a rust. Remember the term, a rust-colored sputum? There's blood in the sputum, all right? People who have this condition, they have respiratory distress, high fever, sharp chest pains. They're confined to bed. This is pneumonia, very serious pneumonia. All right, terminologies for a clinical term, lobar pneumonia. An entire lobe of a lung is infected. All right, here's another term, double pneumonia. That's 2. Both lungs are infected. That's pretty bad. And then we have bronchopneumonia, the bronchi, the respiratory passages, and the lungs are infected. All right? Again, generally what we see when people die, typically they're around this area. They're very old, all right, or elderly people. If it occurs in very young people too, it can be quite deadly. This is what the organism looks like. Here's a chest x-ray, by the way. That dark color is normal. There's a person with double pneumonia. You can see both lungs here are infected and inflamed. It's caused by this organism here, Streptococcus pneumoniae. Right? There's a vaccine for it. There's a couple of vaccines. One's called PCV13, Prevnar 13. This other one is called Prevnar 23. Again, don't worry about treatments. I will tell you when I want you to memorize treatments. All right, I said that to you before. There's a vaccine for this one. But the problem is that vaccine doesn't cover all the strains. In fact, there's over 90 strains of Streptococcus pneumoniae. These vaccines cover either 23 or 13. All right? Okay. Other organisms that cause disease in the lung? Mycoplasma pneumoniae. So what do I want you to know about this organism? This organism doesn't have a cell wall, so it's very hard to culture in the laboratory. All right? So how do you diagnose this? Well, if a person has, first of all, you screen that person for all those other agents we just talked about before. If you can't culture anything, you do a screening test. This is called, and I want you to remember this in red, a cold agglutination screening test. Here's how this works. A person who has Streptococcus pneumonia, again, a bacteria are very difficult to culture. We can actually use special plates to culture the organism. It's pretty cool to see them. They look like little fried eggs. All right, but that's not your concern here. But how do I screen this if we can't culture them in the laboratory? I can take the patient's blood and do a CAST test. So this stands for cold agglutination screening test. Here's how this works. You take the patient's serum, all right? And in another tube, you have blood cells from a different individual. This is type O blood, red blood cells. And then you put the patient's serum in there. If the person is infected with Mycoplasma pneumoniae, here's what's going to happen. This blood would clump at 4 degrees, but not at 37 degrees. So that's called agglutination. If you did a blood grouping test last semester, you can understand what this means. People who have Mycoplasma pneumoniae, they have antibodies in their system that would cause red blood cells of the O type to clump at 4 degrees, but not 37 degrees. Hence, that's called a cold agglutination test. All right? Now, another thing, we talked about antibiotics. We can't use any of the beta-lactams for this organism. Why? Again, you guys remember this, right? Beta-lactam antibiotics attack enzymes that make cell walls. Well, these bacteria don't have cell walls. So all the beta-lactams or anything that targets cell walls would not work. The organism does not have a cell wall. Now, usually the disease is mild. So unlike Streptococcus pneumoniae we just talked about before, this organism can cause walking pneumonia. All right? So people can still get up and walk around. It's not as devastating as we saw before. There's a link to Guillain-Barré syndrome. This is where the immune system starts destroying the peripheral nerve. But again, this is nothing is really known about why this occurs in some patients. All right? Now, next list on the list, again, remember what I want you guys to know. Names of organisms, disease they cause, and signs and symptoms. All right? Next disease on the list is Legionella pneumophila. This organism causes a really nasty disease. It's called legionellosis, or Legionnaire's disease. We first saw this in 1976, and here's why. Back in Pennsylvania in 1976, July 21 to 24. This is another class in history, so don't memorize these dates. The chapter of the American Legion, they were having a meeting in a hotel. All right, they were having a convention, the 58th convention in Pennsylvania. About 212 people became ill, and 34 people died. That's a pretty high death rate. It's not just a random thing. One person dies in that convention. No, you have 34 people out of the 212 that became ill. Now, they looked for the pathogens, and they weren't able to identify any. But ultimately, they actually identified this organism, Legionella pneumophila. What I want you to know about this one, it causes Legionnaire's disease. There's another form of disease, it's called Pontiac fever. Again, but that's mild compared to Legionnaire's disease. But here's the link I want you to make. This organism lives in water. So it's free living. It lives in the environment. When they did the study on this, here's what they found out. This organism passed through the air vents, the air conditioning vents, and it went, people actually acquired the organism by this mechanism, all right? So air conditioning vents, little puddles of water, lakes, this organism is out there, very dangerous. Now we're winding down, so a few more minutes will be done with this chapter. All right, another disease is Q fever. Now look at me for a second. We're talking about a lot of things, right? What I want you guys to know, names of organisms, I'm going to say it again, disease they cause, and signs and symptoms. If there's a vaccine, I want you to know that too, all right? Those are the major things. There's other things, of course, when you read the slides, but those are the things I'm trying to focus on. Now, this disease is called Q fever. It's caused by Coxiella burnetii. This organism is a very small bacteria. It's an obligate intracellular parasite. Remember what that means? A living cell is required for this one to grow. So this can't grow outside of a living cell. And primarily, you find this in livestock, cows, goats, sheep. People get infected by actually working with contaminated animals. Imagine I have some bacteria on the fleece and you breathe that in, it gets into the lung. But generally, this is a very rare type